Hey folks, this video represents the solution to question number 4 on the projectile set. It's about the howitzer. A howitzer is basically a really big gun on wheels, and it fires artillery at very high velocities, really high up in the air, so it has a very high trajectory. And so the question you're being asked is about the final velocity of the projectile after a certain amount of time. And in general, working with velocities or final velocity is one of the more taxing things to do. And so we're going to talk about that as we solve the problem. To, again, work with projectiles, we have to break our initial velocity into its horizontal and vertical components. And so I'm going to do that very quickly. The initial x velocity is going to be 680 times the cosine of 40 degrees. And so that velocity is going to be 521 meters per second. So that's important and also very nice because that velocity is not going to change. Any projectile is going to have the same horizontal velocity at all points in its trajectory. So we get to keep that number 521 and use it at the end of the problem. For initial vertical velocity, that's going to be 680 meters per second times the sine of 40 degrees. And so that is going to be 437 meters per second. So the thing about that is that that velocity is going to change as soon as the bullet leaves the howitzer, or the shell leaves the howitzer. That velocity is going to start to go down. And so what we want to figure out is what is the vertical velocity after 8.5 seconds, and then use that in combination with the initial x velocity to figure out the final velocity. So the nice thing about this question is that we're not really concerned with distance. We're just concerned with velocity over time. So my first step, I'm actually not going to make a chart of data because it's all about velocity and nothing else about position. So I'm going to make a first move would be to find the vertical velocity after the time requested in the problem, and the time was 8.5 seconds. So my vertical velocity is going to be my initial vertical velocity, 437, plus AT. Now acceleration due to gravity is negative 9.81, and I'm multiplying that by the time, which is 8.5 seconds. And so the vertical velocity is going to be a positive number. It's going to be 354 meters per second. Now the deal with the howitzer is that because it's launched at such a high velocity, at such a high angle, it takes a long time to go up and come back down. So 8.5 seconds doesn't reduce that velocity enough to change its direction. So this artillery shell is still on its way up in the air. And so we want to take a note that we got a positive answer. If we got a negative answer, then this bullet is traveling downward, but it's a positive final velocity. So we are going to take that into account. The only other thing I have to do is now to figure out what the value of v is and what direction it's pointing in. So, I started with these two components, positive 521 in the x, positive 437 in the y. I still have that 521. I now am down to 354 in the y direction. So I'm going to draw a triangle. It's maybe going to look like a little flatter than I started, just to kind of show that there has been a change. And I'm going to put v here. This angle is going to be different. It's no longer going to be 40 degrees because the vertical velocity is different. That angle should be smaller. And then vy and vx. So these are going to be like the final velocities. And I make another triangle because velocity is a vector. And I'm going to assume that it's pointed at an angle. And so I need to use the triangle and trigonometry to figure out what the speed and direction of that is. So as far as finding the value of v, I'm going to use the Pythagorean theorem. So that's the square root of vx naught squared plus vy naught squared. So 521 meters per second squared plus 437 meters per second. nope, sorry, I messed that up, plus 354 meters per second squared. So just kind of ignore that mess. So I take the initial x velocity and the final y velocity and put that into the Pythagorean theorem, and I get the number 630. So um, the velocity of this object has decreased. It was 680 meters per second, and because it has been flying through the air, it's been decelerating. So the overall velocity is 630. I also want to find the angle, and I can do that using inverse tangent. And so I'm going to do Vy over Vx, and so that's going to be 354 divided by 521 meters per second. And so theta is going to be 34.2 degrees. Okay, so those are the two components of the final velocity. And so to write the final answer, I'll do scientific notation to preserve the three sig figs. So essentially what amounts to 630 meters per second at 43.2 degrees. And because the y velocity was a positive number, this is 34.2 degrees above the horizontal. So that problem deals specifically with velocity. So it's nice, you don't have to deal with a lot of different equations. But what's tricky is you have to remember, conceptually speaking, that as soon as you launch a projectile, you are locked into an x component velocity that is constant, but your y velocity will constantly change as the projectile flies. So after 8.5 seconds, the speed is reduced and the angle is reduced from 40 to 32 or 34.2. And that is that.